So the next one we're going to do is this one here. This is on page 6 of 14. Now we haven't mathematically learned how to deal with the vectors with using trigonometry. We've just done them on this way graphically. That's what I'm going to show you now. And that's what you worked on. So this is in your packet, so you should have your packet out so you can work on this now unless you've already done it. And we end up going off the map on this one. I don't know what I did, if I made a mistake somewhere or something. Now, we need rulers and protractors, so there should be some around, but you should have a ruler or protractor as well. You got 2 of them? So she could loan you one if you need one. This is a cool one. It's even got your name on it. Maybe you don't want it to be loaned. So there should be some laying around, or you could share with your neighbor too. Okay. Now, a vector is represented as what? An arrow, right? And that arrow has a length which represents the what? The magnitude. And the magnitude is the number part and the unit. So it could be 5 miles that vector represents. Okay? The way it points tells you what? The direction of it. Okay? Now vectors add together. When you add together, you add them to from the tip. You take the tip and you draw it to the head. And then the next one would you start at the tip and draw to the new head of it. Head to tail. We did tail to head, sorry. You start at the tail to head. They go head to tail when you add them. Yes. Mm-hmm. Let's go just there. Although it really wouldn't matter because they still end up in the same place at the end, which is where they started. Okay. Then there were a couple other things like the difference between distance and displacement. Well, first distance, okay? Distance is just a matter of, you're not really interested in direction for distance. So if I start here and I run down the hall, then I run back up the hall. Say the hall is 25 meters long. What was my distance that I traveled? 50 meters, right? Make sense? However, displacement is a change in position from where you started to where you ended, both in magnitude and in direction. So if I started in the hall and I went to the end and came back, what was my change in position? 0, nothing. In this case, we're going to go west, we're going to go north, and then we're going to go north again. And my displacement is going to be from where I started to where I ended, and we get the length of the arrow, and the direction is going to be which way that's pointing. Okay? That's going to become clear as we go through this example, which you can fill in. The good thing is we're filling in a lot of this packet, so you won't have much work over the weekend. Right? And as I think about it, try to watch like 30 minutes of the video tonight. Okay? Yeah. Of the next video, part 2. 30 minutes. Because some of you still have the lab to write up, so you're behind on that. The idea was that the lab, you could have written that up over the weekend. But, you have your parties to go to and your friends to hang out with and all of that. So it seems like you have to spend 8 hours on physics, but it's just because you put it off to the last bit. I know you're busy. Yes. shouldn't. Whoa, that's weird. Oh, you're on the wrong page. You're on 12 of 14. It's 6 of 14. Okay. Now, so the first thing you do with these is you have to convert 10.5 miles to centimeters so that we can put it on here. And 10.5 miles, well, it's just like a fancy version of 1, like we did with the unit conversions. But in this case, it's 1.5 miles to 1 centimeter. And now that will get us to centimeters. And what is that? What's 10.5 divided by 1.5? 7. So 7 centimeters. Yes. So you're just taking the miles using this scale up here, and you're going to convert it to centimeters. Yes. The fancy version of 1 is 1 centimeter over 1.5 miles. That's the fancy version of 1. Your conversion is a fancy version of 1, because based on this, they're equal, right? So 1 centimeter over 1.5 miles means they're equal. It's equal to 1. So 7 centimeters. Now, when I get my ruler out, well, I need that protractor too, so put that on there. And when I get the ruler out, the problem is that these aren't really centimeters. So I have to shrink this ruler down. And then you're going to tell me, if I put it in the middle of A, starting at 7, I did this last period, so is that pretty close to where it should go, right up to like there? Okay. So the blue is my first walking from A, or driving or flying, whatever we did. Starting at A, we travel 10.5 miles west. Okay? The distance I went, I can already fill out, but I'll get to that later. So 10.5 miles is 7 centimeters. Okay? The next thing I do is 9 miles. Well, what is 9 miles? I should have made this blue. Hold on. That didn't work. Whatever. I'll make this red. How about that? There we go. The red. Now they correspond. Now I'm going to do the blue one. The blue one says 9 miles. So fancy version of 1. 1 is the same. 1.5 miles to 1 centimeter. And 9 miles divided by 1.5 is going to give us 6 centimeters. Now that's at 30 degrees east and north. Now watch how I use my protractor. East and north means this is north, and it's going to go 30 degrees east and north. See my hand? Yes. It does. Right across from the 0. It's the bottom. It's right. It's just the bottom, across from 0. So, on this protractor here, it has a center point. Now I'm going to take that because we add vectors head to tail. So we're starting here at the head of that one, and I'm going to put my new tail there. But it has to go at 30 degrees east and north. So that 30 degrees east and north is going to be, here's north, so 10, 20, 30. You see what I did there? There's north, 10, 20, 30 degrees east of north. Capiche? Okay, good. Now, I have to do the 6 centimeters, so bring this over, flip it around. And I'm lining that up. Now I'm ready to draw in. Okay. Now I got the 2 pieces of my stroll through northern towns in Buffalo, Western New York. I'm in Grand Island. Then I go off the map because why not? Okay. Okay, right, but that's not how we're going to do it because it says east of north, right? This is north, so we count over 10, 20, 30. So it should be this. Yeah. Yes. No, so it's not 30 on this. If you go to the end of yours like that, it's 30 degrees east and north. So here's north, right? 10, 20, 30. Okay? That's all right. Just redo it. It'll be fine. Okay? We're good? Now we say 4.5 miles. 4.5 miles we need to convert to centimeters north. So 1.5 miles for 1 centimeter gives 3 centimeters. So 3 centimeters, oh crap, crust I mean, sorry. It goes off of the graph. I don't know how somehow in the changing I messed it up. But that's okay, we'll go off, it's no big deal. Oh. Okay, so now, stop it. Jeez, really? Now it's back, okay. It's trying to think for me. Then north. How many centimeters I gotta go? Trace. Okay, so up 3 centimeters. I think that was supposed to be south, but that's okay. That's what it says. So these vectors are arranged head to tail, aren't they? And we've drawn the path on our map. But now we have to draw the resultant. The resultant is the sum of the 3 vectors. And the 3 vectors, when you sum up 3 vectors, you arrange them head to tail, and then you go from the start where you started with your first vector to the head of your last vector. So we started here and we ended there. Now you can use your ruler to draw yours. I have a magic one, so it's a little easier for me. Okay? There I drew the resultant on the map. Now this thing right here, delta S, it represents something, and it represents the distance. Now the distance is just the sum of how far you went. That's all it is. So if we had to sum up this distance here, how much did we go initially? 10.5. Yeah. And then we went 9 miles. And then we went 4.5 miles. So this is the distance. Delta S with no arrow means distance. The reason it's S, S is for space. Okay? So this is distance there. And that would, the sum of that will give us 24 miles. change in position, or change in space. In this case, just change in space without thinking about the direction. No. No, this whole thing, delta S, is the distance. Yes. No, it's fine like this. Now this delta S with an arrow over it looks like this. Actually, that's delta S. That is the displacement. And that's the value from where you started to where you ended. So this vector here, the resultant sum of all three vectors, is the displacement. Exactly. We're going to first measure this in centimeters. Okay. On mine, with mine being slightly different, I get about 9.1 or so. All right, so they could range a little bit there. There's some play in that, you know. So if I take the 9.1 centimeters and I change that to miles, well, I know that for every 1 centimeter, it's 1.5 miles. So I'm going to get 13.65 miles. That's the magnitude part of the displacement. Yes. Yes. But the displacement doesn't care about the root. It's only the value from start to where you ended. We need to figure out the degrees that we're at. Yes. Now, that will give us our direction. This little key up here says E for east. So we're going to give a direction in terms of southeast, well, in this case, northwest. So what we're going to do to get that direction is we're going to take our protractor and we're going to stick it on the end of the purple. See where I stuck the crosshairs? Right on the end of the purple. And I read that over, and I can see that I'm 10, 20, about 28 degrees west of north. You see that? In this case, yeah. Well, it's just got to relate to an east, north, south, east, west system. Now, it's important to be able to do that. So, look, it's 10, 20, 8 degrees west of north. Do you see that? Here's north, 28 degrees west of north. We put that on here. Well, yours might be slightly different. Remember, I'm doing it on the board first off. I see some writers still, so we'll let people finish. How much different? If it was like 80 degrees west to north, we have a problem. Probably all right. See, I'm doing it on the board first off. It's graphical, so, good enough for government work, I guess. That's what we would say with geologic maps and stuff. When you're making a map, it's just government work. You just quick. It's not even. It's just dumb. But you have to be a geologist to find it funny, I guess. Maybe, or maybe not even then. I don't know. Does he? Yeah, you see? Yeah, same thing. Okay, now moving to the next problem. And this one's the one that Michael was looking at that he thought was this problem. Now some of these other stuff, we're going to do this after we watch the next part of the video. So we're going to start on it tomorrow. So we're going to have a lot of practice with this tomorrow. You'll know half of the stuff because you'll watch 30 minutes of the video. Okay. And then we'll learn the other parts. We'll do a little trigonometry. Well, some of you already know trig, right? But we'll relate it to vectors. It's not none of the now. Some of you should be doing trig in math, right? Right. So you're learning sine, cosine, and tangent right now, right? Well, what are they What are they waiting for? You got to tell those math teachers to get going. I'm just kidding. Actually, we worked to correlate that so you can you'll learn it in math and have it in science as well. So, but they correlate. All right, so now we're going to go on to page 12 of 14. We're going to copy this thing. 12 of 14. Couple things. First, we have a different scale. Now 1 centimeter is what? We also have 0 degrees instead of an east, although then I use southeast in here. Sorry, but that's all right. When we report our final answer, we're going to report it in terms of using 0 degrees. Now this 0 degrees here, it's 0 degrees. This is 0, okay? Straight up north is 90 degrees. Over to the west is 180. And down is 270 degrees, okay? So you're on 0, 90, 180. Oh, 270, right? And then if you go back around, you get the 360. See? Did that look like it hurt? No. Anyways, 10 miles east from B. Then, okay, so east is this way. And 10 miles needs to be converted. It's nice and easy now, right? Because 10 miles is what in centimeters? 5 centimeters. So 5 centimeters for the first step. I need my ruler. Not for this case, okay? Tomorrow when we learn the trig, we'll start using, this is a graphical solution to these, okay? All right, so now this could be slightly different. Does this end up, when you put it right on the B, the center of that square, and you go 5 centimeters, does it bring you to about where this is? About there? Good. Okay, so that's the first step. And then it says 6 miles. Well, 6 miles is going to be 3 centimeters at 45 degrees to the southeast, so down this way. I need a protractor. Well, I probably should have been consistent and wrote on here 300 and 15 degrees. But in this case, I didn't. So I just said 45 degrees southeast. So I just mean that down this way, 45 degrees. So we put the crosshairs right at the end of the last arrow. And 45 degrees would be right down here. And now I'm ready to put on 3 centimeters, right? You see our two paths so far? Does everybody understand that? The next path is 8 miles south. That's 4 centimeters, right? Four centimeters south, straight down like that, right? And now I can answer the first, oh, I have to draw the resultant on the map. So I'm going to go from the start, where I start at B, and the tip there. So we're going right down that little lake over there. "45 degrees. I took the, whoops, I took the protractor, I centered it on the head, I'm sorry, of the first vector, and then southeast is in this quadrant, 45 degrees, 10, 20, 30, 45. You see? And then I went in that line of it. So if you went, well, now let's find the distance. This thing represents distance, right? Delta S without an arrow on it. So it's just simply 10 miles plus 6 miles plus 8 miles, which is 24 miles. The key is to do it while you're not looking, okay? Let's see if I can do it. Well, I did look, obviously. So now, to get delta S with an arrow, displacement, to get the displacement, what do I have to do? I have to measure the resultant. So I take my arrow, or I mean my ruler, and measure the arrow. And I get about 9.4, just to be bratty. 9.4 centimeters. Now, is that my displacement, 9.4 centimeters? No. I'm going to convert it first to miles. 1 centimeter is 2 miles, so that would be 18.8, right? 18.8 miles. Now, if you got it slightly different for yours, that's okay. Are you guys all getting this? Mile? Now, what about, is this it? Is this the displacement? We need direction. We need to get its direction, and we're going to record it as in relation to the 0 degrees here. So to do that, I stick it on the crosshairs. Now this would be 270. This would be 360. This would be 350, 340, 330, 320. See that? One time around the circle is 360, right? So this is 270 down, right? 280, 90, 320. So this is 18.8 miles. Okay. All right. That's probably all right. Okay. That's all right. It's just any questions? Yes. It should be close. It shouldn't be 20 degrees off. Okay. Okay. Oh, well, I don't know how that works. Okay. All right. Okay. All right, good. Now the next thing it says is find the x and y components. So we're going to do that tomorrow. We haven't talked about that in the video yet. So